Okay, so like if you remember the end of the last video, I was like, oh, should I do another one? I'm like, yes, I do. I want to do another one. So let's go ahead and do example. I think it was like example D and E. Just to remind ourselves how to do these and walk through these. And these are probably D and E will probably be the ones that you'll definitely need to know how to do on our next assessment. So follow along and then come to class with any kind of questions. But let me get this out of the way just so I have a little bit more space. So the idea behind D, which is kind of like C, is that we want to switch the X's and the Y's, but use our asymptotes to help us predict the domain and the range. Because remember, domain and range, they switch spots for your function versus its inverse. So remember, we could think of this as y equals, and we could switch this around if we wanted to, which I will in a second. But I also want to make a little chart up here. So if this is k of x, and this is k inverse of x, and then I've got domain and range here. So the domain of k, basically x can't be 0. X can't be 9 because that would give a 0 in the denominator, which means its range of the inverse here, y can't be 9. Okay, so again, those are always the same because you're switching your x and your y coordinates. Now, I learned from the last one that I'm anticipating a horizontal asymptote of 2 here, well, I know it, which will be my range value. Y can't equal 2. So I'm anticipating when I find the inverse that x won't equal 2 either, because it'll be a vertical asymptote. And so let's check it. So let's go ahead and switch our variables. X equals 2y plus 10 over y minus 9. And again, I'm sure you did problems like this in Hot 2 last year. So it's just good as a reminder of what you did. Multiply it across. So x times the quantity y minus 9 equals 2y plus 10. And then we can distribute. So xy minus 9x equals 2y plus 10. And we want to get y's by itself. So, it doesn't really matter which side we put them on. Maybe I'll move this 2y over and move this negative 9x to the other side. So if I subtract 2y, I get xy minus that 2y. Here's my 10, and I'm adding the 9x. And then I can factor out the y. So I get x minus 2 equals 10 plus 9x. And finally divide that across. So y is equal to 10 plus 9x divided by x minus 2. And I think I had called it k, so I might as well call it k inverse, which is equal to 10 plus 9x. I think I picked the exact same pen color, almost, as the background, over x minus 2. Okay, so then as I was anticipating, look at that. There's a vertical asymptote at x equals 2. And that meant that the domain could not be 2. And then think about this range, y can't equal 9. Look where I see that 9. It's in the ratio of x's, right? Which was indicating that there would be a horizontal asymptote at 9. So that worked out really, really well. So be prepared for questions like C and D, definitely, where you're doing those rational functions. And then the other big one would be question E. So I thought we'll look here as well, because it's a quadratic, but it's a quadratic that has a restricted domain. And a lot of times that domain restriction ends on like the vertex, right? So you're splitting it in half. So the best way to do that is, to verify that it's a vertex as well as solve, is to do what I love best with quadratics. And you've guessed it, shout it out loud. You know the answer, right? Completing the square. So I'm going to complete the square. So if you call this x equals y squared minus 8y plus 17, okay, the reason that we have to complete the square is because there's no way to compose a y squared and a y together. So we've got to complete the square. Then I guess I was on a kick there with k. So k of x versus k inverse of x. let's start talking domains and ranges here. So my domain and my range, well, they tell me the domain of k of x is greater than or equal to 4. So I'm anticipating my range of my inverse will also be greater than or equal to 4. Okay. So, but let's complete the square here. So x equals, so y squared minus 8y, leave some space, and there's the 17. So half of that is 4, and 4 squared is equal to 16. But then we immediately subtract 16 to balance it. So we get x equals y minus 4 as a quantity squared plus 1. Okay, so now I can actually solve this equation for y, right? Here's the y, get y by itself. So I'm going to move the 1 over. So it's going to become x minus 1 equals quantity y minus 4. And do you see how nice that was completing the square? That allows me to square root both sides to get that y by itself. I'm introducing the square root. So because I'm introducing the square root, because I'm introducing the square root, I need to pick up a plus or minus. Okay, anytime you introduce the square root to the problem, you are creating a case where you need plus or minus. But the thing is, we have got to pick one because it's only going to be one. It's one, like it's the first context, first problem where it's a plus or minus, but we really need to focus on the or. It's one or the other. It's not both. So when I introduce this square root, so I get plus or minus the square root of x minus 1 is equal to y minus 4. Remember, try to get this y by itself. So we'll add the 4 to the other side. So it's 4 plus or minus the square root of x minus 1 equals y, or is our inverse function. Okay. So the question is, how do we determine, right? How do we determine which sign? Is it plus or is it minus? Well, here's how. Here, right? We knew the range is greater than or equal to 4. So think about this for a second. Here's that 4, right? Here's your 4. And you're either going to add or subtract something to it. Well, if you want to be greater than 4, we better pick the adding, because if you start subtracting, you're going to be less than 4. So that's how we decide ultimately, is by that direction. If you're greater than or equal to 4, then you want the positive, right? If you were less than or equal to 4, you'd want the negative. So it's plus or minus, but we will interpret the context of this problem to be just the plus. So there is my inverse. Now, in this inverse, I know something about the domain because I've got a square root, right? Think about that square root. We need to make sure that our x value is greater than or equal to 1. Otherwise, we're taking the square root of a negative number. So in the inverse, I know x is greater than or equal to 1, which meant in my function, y was greater than or equal to 1 as the range. And think about, where did that come from? Oh yeah, vertex form, right? So initially, if I left this as y equaled x minus 4 squared plus 1, and I drew its graph at 4, 1, and I knew that this parabola existed here, then yeah, I would know the range is bigger than or equal to 1. And that's exactly what I had there. Okay, so I think I'll save F as a warm-up exercise for tomorrow's class. So, but like there are two classic kinds that you absolutely have to know how to do by hand, finding inverses. And we did 2 examples of the first kind, which is the rational function, which is like question D and E, which is kind of spinning here, and also a quadratic completing the square, which is question I guess E there. So did I have 2? Do I have 2 D's? 2 E's? There's E, D. Oh, I guess it was C and D and then E. So, okay. Enough of me with the alphabet. All right. So thank you for watching, and I would, as always, ask questions whenever necessary.